So, tonight what we're going to be talking about are relations and functions. And what you first need to know is what is a relation. When we talk about a relation, we're talking about a set of ordered pairs. And so a set of ordered pairs, a set is just a group. That's the math word for a group. A set of ordered pairs. And an ordered pair is a point. We usually write those with the parentheses, with an x coordinate and a y coordinate. And so a relation is a set of ordered pairs. So that's a group of points, so to speak. So we have a group of points, things that we want to clarify in the ordered pairs. X is the first number, y is the second number. We also know that X is the domain, or the set of X's is the domain, and the set of Y's is the range. Another way to kind of think about X and Y as X is the number you put in and Y is the number you get out. That's a good way to kind of deal with relations and functions. You have an input, the domain, and you have an output, the range. In this day and age with computers and input and output and all that kind of information stuff, it very much fits along with that. So relation is a set of ordered pairs. It can be any set of ordered pairs. It's just a group of points or a group of ordered pairs that go together. In general, we have 5 ways that we can represent a relation. 5 ways that we can represent a relation. And you've seen all of them just about up to this point throughout your mathematical career. The first one is to actually just do it in set notation, to write the set of points. So this is what you use when you have a fairly small group of points. You don't usually use set notation for a very large group of points, but you can. Set brackets are the little wavy brackets. Those are the wavy brackets. And so you could just have a set of points. And so you have your group of points, and that's your relation. So that's set notation. Another way is a table. We can put our information in a table. So we have our X and we have our Y. And so just like doing the set notation, our points go in the table, the X that goes with that Y, and the X that goes with that Y, and the X that goes with that Y. This would be a relation. It's a set of points. It's just a different way of writing that set of points. Another way you may or may not have seen up to this point is called a mapping. And a mapping is basically when you physically show which your domain goes together and your range go together, and then you draw lines to show which X goes with which Y. So if our domain was the X values, that would be the 2, the 4, and the 5. This is our domain, and then this is our range. So we have 3, 7, and -10. Again, input goes to the output, so 2 goes to 3. So it is directional. 4 goes to 7, and 5 goes to -10. This is the input, and this is the output. So this is a mapping. So we can show it in that way. Another way that we can show relations is that we can do a graph. We have our X and Y axis. And so your x-axis and your y-axis, and we have coordinate points. So you can have the point 2, 3, and you can have the point 4, 7, and then the point 5 and -10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be down here. So, we could graph. A graph is one way to show it. And then another way to show a relation is an equation. You can do equations for some relations. Some relations, we have a relationship that we can actually quantify as an equation. Not all relations have an equation. Not all relations necessarily follow a pattern. It could just be a random set of points. But sometimes with relations, we can represent them as an equation. So if we had something like y equals mx plus b or some other equation, you can show relations as an equation. These are your options, the different ways that relations can be represented. So any of these 5 ways are always representing a set of points. They always represent a group of ordered pairs, and they are called relations. They got the name because in general we are talking about points that have a relationship. There's some sort of correlation. So a relation is where that name came from. A specific type of relation is a function. A function is a very specific type of relation. So it is still a set of ordered pairs. I can still do a mapping or set notation or a table or an equation or a graph. But what makes a function is it is a relation where every x has only one y. Every x has only one y. If we think of it in the input and output perspective, every time I put a number into the function, I'm going to get the same number out. There's not two possibilities to come out for any one input. So every input has only one output. Every input has only one output. Okay, so every input can only have one output. I think of it as a consistency issue. In a function, you want the relation to be consistent. And so every time I look at the x value of 5, I want it to have the same y value with it. Ways that we can figure that out kind of depends on what way we're showing that particular relation. So for example, if we're looking at set notation, if I have set notation, let's say I have the set 2, 3, the same one we had last time, 4, 7, and 5, negative 10. It's a small relation. When I look at this, I'm looking for consistency. So I've got 2, and when I plug in 2, I get out 3. Well, that's the only place I have 2. So every time I plug in 2, I'm going to get out 3. If I plug in 4, I'm going to get out 7. And it's the only 4, so every time I get 7. If I plug in 5, I'm going to get out negative 10. This one was consistent. It is a function. If I look at another set, if I've got 2, 3, 4, 7, 2, 8 as my relation. When I look at this, when I plug in 4, I get 7. But when I plug in 2, here I ended up getting 3 out of it, but over here when I plugged in 2, I got out 8. That one input had 2 different outputs. This one is not a function. Okay, so every input can only have one output. If we're looking at a table, it's very much the same idea. I can only have one output for every input. So if I have an XY table and I have 5, 3, negative 2, 7, 6, 3, negative 4, 7, all right, I'm looking at this table and I want to figure out whether it's a function or not. If I plug in 5, I get out 3. Every time I plug in 5, I get out 3. Every time I plug in negative 2, I get 7. Every time I plug in 6, I'm going to get 3. Every time I plug in negative 4, I'm going to get 7. Here's where the consistency is. Now, the fact that 3 got used as an output twice, that doesn't actually matter. What matters is that every input has only one output. It doesn't have any rules about how the output can be repeated. In fact, you can have functions. So this one is, in fact, a function. You can have functions where the output's the same all the time. It's a boring function, but it's called the constant function. You know, I could have a table and I could have 1, 2, 3, 4, and all these inputs are different, but I get the same output every time. That is still a function because every time I plug in 1, I get 0. It's consistent. I can't plug in 1 and get a different answer. So that makes it consistent, and that means that, yes, it is a function. Now, on a graph that has a very visual and the mapping as well. For the graph and the mapping, it's a very visual kind of way that you see it. For a mapping, if I've got my domain and my range, here's my x's, and here's my y's, I want everything in the x bubble to only have one output. So that means that every number should only have one arrow out of it. If it has more than one arrow coming out of one of these inputs, then you know it's not a function. Each input can only have one output. So if it looked something like 1 had 2 arrows coming out of it, that's 2 outputs coming out of one input. That would not be a function. Again, we can have outputs that are repeated as much as possible. This would still be a function. That one's a function because each one of these inputs only has one output. That's what makes it a function. On a graph, the visual representation of that consistency and that non-repeating itself is often called the vertical line test. So the vertical line test will tell us if you get that repeating in the y, because if we have more than one y for an x, it's going to hit a vertical line. So we can look at a graph, no matter how crazy the graph looks, I can tell whether it's a function or not because it will pass the vertical line test. If I can draw a vertical line through it and it never hits more than one point, like I draw all these vertical lines and it's always only ever hitting the graph in one spot, that means that yes, it is a function. But if I have a graph and I can draw a vertical line through it and it touches the graph in more than one spot, that fails a vertical line test. And so this one is not a function. So the vertical line test is how we test the graphs for that. So things to remember about relations and functions. Relations are just any set of ordered pairs. You can do a table, set notation, mapping, graph, or an equation. To be a function, it's any relation where every x has only one y. Domain is always the set of all the x values, and range is always the set of all of the y values.